seem to get to the right app. There we go. Okay, this is, the problem was off of the 2013 AP exam. This was number 5 on the free response for the 2013 AP Physics B exam. So, this is an ideal gas question using the first law of thermodynamics and using the ideal gas law in tandem here. And also we are required to know something about the properties of these different processes. So first off, in a certain process, we've got 3,200 joules of energy added by heating, 2,100 joules done on the gas of work. We're looking for the change in internal energy. Now this one's pretty straightforward. Delta U is equal to Q plus W. The only trick here, the only thing that you have to be careful of is, is Q positive or negative, and is W positive or negative? Well, by definition, with how the AP test is set up, this is actually on your formula sheet. We define work to be positive when it's done on an object. So the work done on a gas is going to be positive. So, and then it tells us that heat is added to the gas, so that's a positive as well. So we've just got 3,200 joules plus 2,100 joules, and we get 5,300 joules for this one. Okay, indicate whether let's see, each of these increases, decreases, or remains the same. Volume. Volume we can tell from work. So we can do this two ways. We can picture the situation here where we have this piston involved, and it doesn't mention a piston, but this is just a good way to visualize any of these ideal gas laws, the first law of thermodynamics questions. You can think of them all as being with pistons. So if work is being done on the gas, that means that the piston is moving downward. The piston is applying a force down on the gas and moving, compressing the gas. If the gas were doing work on the system, then this piston would be moving upward. It'd be doing work on the piston. The gas would be doing work on the piston. So here, since work is positive, our volume decreases. And our justification is that work is positive. You can also think of this in terms of the equation. Work is equal to negative pressure times the change in volume. Since work was a positive number, the only way that happens is if the change in volume is some negative value. Pressure can't be negative, it has a minimum value of 0. So change in volume is negative, that means volume decreases. Second question, temperature. Does it increase, decrease, or stay the same? Temperature is proportional to U, the internal energy. Now this one really tricks people up because we see this word heat and heating, and we think, okay, well, heat, that goes along with temperature. If it's too cold in my house, I turn on the heat. But temperature doesn't go directly with heat. Heat is just energy being transferred into or out of a system. Temperature goes along with how much energy is in that system. Not how much it's changing, but how much is there. So if if U, the internal energy, is increasing, then temperature is increasing as well. So delta U is a positive number. That means we're increasing internal energy, which means that temperature is increasing as well. And the last one, pressure. Increase, decrease, or stay the same. Let's just pull out the trusty ideal gas law equation. Okay, so we've already done volume. We said volume was going to decrease. Temperature, we said, is increasing. The number of moles, we'll say, is constant, stays no change there. Ideal gas constant won't change either. So if pressure is decreasing and temperature is increasing, if volume decreases and temperature increases, what does pressure have to do? It might be easier to see this if we rearrange and make this NR times T over V. and T is increasing, V is decreasing. So we see that this fraction overall is increasing in value. So that means that pressure must be increasing as well. Okay, suppose in a different process. That is a key phrase here, a different process. That means whatever you found out in parts A and B, forget about it. It's not going to help you here. Different process. We do 800 joules of work on an ideal gas. Okay, so work is 1800 joules at a constant temperature. Hey, remember how we talked about temperature being linked to internal energy? Well, if temperature doesn't change, internal energy doesn't change either. So delta U is 0. There's no change in internal energy for constant temperature. Okay, and then are we, with heat, are we adding energy by heat? Are we taking away energy by heat, or energy is moving out of the system by heat? Or is no energy transferred by heating? Again, that constant temperature, that's going to throw people off. They think, well, if temperature stays the same, it must mean nobody turned the heat on, so heat must be 0. We haven't transferred any energy from heat. But that is wrong. Temperature is constant because heat is changing, because there is a non-zero heat, I should say. We're doing work on this system. So if there's no energy changed as heat, then the internal energy would be increasing and it'd be getting warmer in there. So that means we must have heat leaving our system. The other way to think of this is delta U is equal to Q plus W. Delta U is 0, and W is a positive 1800 joules. So that means that Q is a negative 1800 joules, and that is heat that's leaving the system. Energy is transferred out of the gas.